The assumption by all parties that software should not consider the possibility of error leads to the most fatal failures. Not tells developers to check your code anyway, somehow, and so on. Specially trained people at the end who test the results in device in a whole or in part without distracting other people in the assembly line. Let's say why in Google don't exist testers. Well, they exist, but they do something completely different. We all saw the QA test badges on various electronics 30 years ago. Obviously, there was some kind of separate testing department in its production. When you have some technically complex device on the assembly line, it's logical if you have specially trained people at the end who test the results in device in a whole or in part without distracting other people in the assembly line. It would seem that the assembly line tester of a radio receiver and the software are no different. Even some terms like smoke tests have carried over from those days into modern engineering. I noticed that many people have the feeling that in software development this also applies. Just add specially trained people to test the result and the quality of the software will be consistently good, or at least with an acceptable percentage of rejects. However, we see from funk companies that it's not the case. For example, the book How Google Tests Software points out that the Googlers think the developers have all need to get feedback from users and runtime environments, and software engineers in test and test engineers they marked as deprecated, and moreover they never test each feature software as we see it in many other less successful IT companies. How so? Hello! Today we are going to talk about a whole and very large class of people – testers. It would seem that the division of labor leads to increased productivity. So, do we need testers? The fundamental problem of testing with separate persons are what we are going to talk today. I will say right away that testers are not new to my company. We produce a lot of code, and for a long time we thought that developers should save their efforts and produce value, while testers, and we had them incredibly cool, should carefully check the completed tasks. The fact that this was a variance with agile practices seems to us a mishap. Well, the smart guys didn't mention testers. Maybe they just forgot? This contradiction forced us to make step-by-step experiments in testing, the result of which I will tell you about after the theory. I want to start this complex topic with how the Cynefin framework responds to what place testers have in value-add chains. A lot of some contraction, guys, so. We know that testers are there when building roads, and testers cut scores to reconcile actual and planned composition, and when assembling a radio, a tester brings out key parts or even just plug device in a socket. That is, testers are there in linear, it is simple and complicated environments or domains, where the key to success is execution of any kind of regulations. With regulation, the work of the tester is simple and straightforward. It is clear what and clear how to test, and the test result is unambiguous, either conforms or deviates. Now let's look at the complex or confusing or tangled domains in which the key to efficiency in the use of agile methodologies. Let's take a close look at famous agile principles signed by the best minds in modern software engineering. Individuals and interactions over process and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. It is not rules and documentation are important, but the ability to work with feedback and readiness to change on that feedback. If you haven't seen the video about Cynefin framework, which I often refer to, be sure to check it out in the description below. Now only important to understand that there are types of processes called domains in which the pipeline is more effective, and there are domains in which our interaction and experience in the team is more effective. That's why in Scrum and continuous delivery and other agile practices, the frequent delivery of value and the willingness to get feedback from the product, there may be feedback from customer itself or monitoring system and everything else, is in the first place. Can the tester be the one providing feedback? Can he work as well as an assemble or in construction? To simplify things, let's take only the most popular testing, functional. It is QA must somehow understand why a task was created and identify flaws. In the ideal environment, we have good and responsible developers and testers who went into testing not because they went hide anywhere else, but because they feel that's what they called to do.
My choice.
In such an ideal environment, which I don't know who has yet been able to achieve, there are many challenges. The first problem is the problem of implicit delegation of responsibility. You, as developer, have to check your own work before you pass the code on. After all, if you don't test, you're initially giving away a piece of code that will likely come back to you. However, with a tester, you know that there will be another tester after you to check your code. Instead of scrutinizing and thinking about how to get feedback from your product to yourself, you want to save yourself time and pass the code faster. Note that this always happens implicitly. Not as developers to check your code anyway, somehow, and so on. But in reality, that's what happens. It's not a problem on the conveyor belt, because every function has a clear sequence of results. If you're constantly turning the screw wrong, that's an excuse to interfere with the processes or with a person. In software development, every task is a little bit unique. With a separate tester, the developer starts to think that his job is to deliver code, not to deliver value. The more the tester identifies bugs, the more the team will return to scroll.
It's not a liquid!
At the same time, tasks with bugs will still get the product, but now it's not only the developer who is to blame for these bugs, but the tester as well. It is his job not to miss any bugs on production, right? The second point is to reduce the speed of development. Why do we hire a tester? To speed up and improve the development process. And what happens when you have a tester in real life? First, you need to communicate the value to the tester more accurately. You can keep everything in your head and in your mind, and the requirements for task description are starting to become more complex. Now, more and more time must be spent on a formal description of the task, so that the tester has something to lean on when accepting the task. Note that in a normal assembly line, this is not a problem. There are instructions on how to tighten the nut and how the soldering should look on the schematic. In development, on the other hand, this is a fundamental problem of a complex environment or complex domains where the criterion for execution, definition of done, is defined for each chip. Second, the developer having submitted task A for testing and take the progress on next task, task B. After all, even if the tester does not have any task from other developers, the tester will need time. Time passes and the tester identifies errors. He returns those bugs to the developer, and the developer is distracted to fix this bug, but he is already in the context of another task, task B, and it takes him some time to both read and understand the way of reproducing an error, and remember the meaning of the task, and correlate this to other code of this task. He again dives into the complex of problem in task A and then comes back to problem B. The book Focus, the Hidden Drive of Excellence, see the link below, clearly describes the problem. This leads with a simple example that I like to retell to developers. Write the phrase, two things are infinite. Now write the same phrase by going through one letter of each word. First the first letter of two, then the first letter of think, and then the same for are and infinite. Then take on the second letter in each word. I saw a lot of people are surprised at how much slower and with errors the second process is. I'm not even speaking about the fact that the developer fixes one error but doesn't remember the whole task. He or she is more likely to make another error with his or he edits. The third problem is an increase of bureaucracy. In the last example, pay attention to how process of describing tasks have become more complicated. Now you need more unambiguous description of tasks, and you won't get away with a sticker on the board. Not because the tester can describe a flow in words, it usually happens that way, but because the developer and tester look at tasks differently. One behavior seems right from the tester side and another from the developer side. In order to avoid unnecessary conflicts on a large scale, and we are discussing exclusively industrial scale development here on the channel, we need to be able to appeal to something. Any attempt to court the number of bugs and reopen tasks will lead to fertile ground of conflict in the team. For example, why did the tester reopen the task if it's not technically a bug? I have had enough of such conflicts in personal experience. The first problem is the estrangement of the developer from the product owner. If we test a feature for a user by a separately hired tester, explicitly or implicitly, the developer begins to know less about the user from the user himself. Ultimately, it's easier for the developer to imagine his role in the task without understanding how that relates to value. This affects quality in the most negative way. The authors of How Google Tests Software point out that the automation, the development of collection and control tools, and the willingness of rank-and-file users to give feedback leads even for Google-sized companies to become test engineers with a narrow specialization in security and process management. To summarize the problem, the implicit delegation of responsibility for quality and the assumption by all parties that software should not consider the possibility of error leads to the most fatal failures. If a developer doesn't initially consider that something can go wrong, doesn't initially cover the code with tests, and doesn't worry about the highest rate of feedback collection through logging and dashboards, it slowly sets a stage for very large-scale failure. I think enough about the problems here. Let's break down the cases where testers are acceptable on the team. Fundamentally, testers are needed when the team fails to deliver the quality on their own, and they need help. When is this possible? When the testing process is too specific and has many nuances. For example, a mobile application developer can test under several platforms in emulator in real devices, and he must do it. But then it is necessary to ensure that everything works correctly on the other 40 devices variation, especially if specific hardware with no software emulation is available. Some rare controllers of second-rate manufacturers and so on. This is not inconsistent with value responsibility. If, for some reason, it's critical and can be covered by functional tests, which must also be written by developer, it's good use of testers. Note that testing for popular browsers for front-end developers is not such case. Usually, functional tests cover testing much more effectively than testers. It's not a problem if a button floats in some rare browser version. And it's not 2010. We have automated tools for pixel-by-pixel DOM analysis for all browsers today. Another case which is used by industry leaders. The tester is a manager who helps build testing processes for the team. This manager defines test design, defines areas of special expertise, certifies teams for quality, manages the ability of collection process and response to user feedback, by developers of course. A third case where high specialization is required is in security or legislative specific and continuous quality audits. Even in banks, this area is very small and actively demanded only in technological mega corporations, which have many systems that operate as a single unit on all continents with a bunch of legal and other specifics. Let's just say that these professionals work outside of value delivery and just regularly study the code, and if they want to share the experience of identifying a particular vulnerability, include that part of the automated test in the code, which then has to be maintained by the team. By the developers. These testers are highly trained elite special forces that need to have a right culture and expertise around them to operate. I hope I covered the topic. Thank you to be patient for my English. That's all for today. Bye.